Greetings, everybody. So, what I have up here is something like question 12 on quiz 3. And I know that when you take quiz 3 and you get to question 12, it might not have these exact numbers, but I'll go over the concept for how you would solve it. Okay. So, we're given this normal distribution, and I noticed that on the actual graph here, I'm given the mean. So that's this number, 2295. And I've given this also the standard deviation, 583.4. Okay. And this is the distribution of energy consumption. And we can read it further if we want to. But here's what it's asking us. It says, what energy consumption level represents the 9th percentile? Okay, so you might think like one way to understand this graph is that most people have an energy consumption right around here in the middle, where most of the area under the curve is, right around 2295. And very few people have an energy consumption, reaching 4,000. Why? Well, because there's not much area, okay? So the more area there is under the curve, the more of the population we could say is around whatever number is at that spot, okay? Now, the 9th percentile is the energy consumption such that it's more than 9% of the population. Here's how we figure that out. First of all, we'll open StatCrunch because everything I show you with the normal distribution I do on StatCrunch. So we open StatCrunch and then we go to calculators and then normal. And when we do that, we get the normal calculator, okay? Now, every normal distribution can be different, and what makes them unique from each other is the mean and the standard deviation. So I'd have to put the mean in, which was given to be 2295, and I'd have to put the standard deviation in, which is 583.4, in order to be applicable to this problem at all. Okay, so I've got the correct mean and standard deviation. Now, I was just saying that if I want the energy consumption that is the 9th percentile, that's the energy consumption that's more than 9% of the population. So the way I could do that on this normal calculator is I put in 0.09 representing 9%. And the number that shows up here is the energy consumption on the horizontal axis that's more than 9%. And that's what I want. Okay, so I do a compute and it says 1512.8. Okay, so right there, this red portion indicated to the left of it is 9% of the entire population of people that use electricity in this problem. So it should be 1512.8. I noticed though it says round to the nearest whole number, integer is a whole number, so notice it says 1513. Okay, so that's how I get it, right there out of that number. This represents the 9th percentile. I could do the same thing for the 22nd percentile. I wouldn't have to change anything about this, but put 0.22 for 22%. Okay, so this number right here, this energy consumption that looks just below 2,000 is more than 22% of the population. And that's 1844.5. If I round to the nearest whole number, it's going to be 1845. Okay, this last one reads a little bit different. This is the 3rd quartile. So quartiles are like percentiles, but the verbiage, the wording sounds a little bit different. The 1st quartile is the 25th percentile, meaning more than 25% of the population. The 2nd quartile is the 50th percentile, more than 50% of the population. The 3rd quartile, you can probably see where I'm going, is the 75th percentile, more than 75% of the population. So in order to get the 3rd quartile, I want this to be 75%. Okay, 2688.49. Okay, so that's this number right here. 2688.49 is right here. And it is more than what's in there in red, 75% of the population of people that use electricity in this example. Okay, so I let's see what it says there. 2688. Remember it says round to the nearest whole number? Well, 2688.4 does round it down to 2688. That's why it's like that. Okay, so that's how we can do question 12 from the quiz. I think StatCrunch does most of the work for us. We just have to navigate StatCrunch and know how to use the normal calculator. Other than that, it might catch you about what the third quartile is, but that is something, if you wanted to look back, that was introduced in somewhere for test 1. It's in one of those old videos if you wanted to look it up.